Okay, the next question that was asked dealt with functions. Okay, now we can clearly see on our diagram, the sketch shows the graphs of f of x, which is k over x plus w. Now we all identify that as this hyperbola. Okay, so here we have f of x is equal to k over x plus w, and then we have a line equation which lies over there. Okay, and that line's equation is g of x is minus x minus 1. Then they say the asymptote of f, which is the hyperbola, passes through the point r over there. Now remember, if you look carefully, r lies on the y-axis, so quite interesting. The line passes through the same point. So the y-intercept of the line is also the y-intercept of that line over there. Very, very important. Okay, let's see what they asked us to do. They asked us, they gave us a point T over here. They didn't really tell us where T lies, so we're going to assume that it lies on the hyperbola. Then P and Q appears to be the point of intersection of the hyperbola with the line. Okay, so let's see. I think that is all the information that we have. So let's see what the first question asks. It asks us, write down the coordinates for point R. Folks, it's for 1 mark. Okay, so a straightforward answer is all that is necessary here. The coordinates for point R. Okay, let me just get us a nice piece of paper that we can write on here. The coordinates of point R for part A is 0 and minus 1. The y-intercept of that line, which we read off the equation of the curve. Okay, so that's for a beautiful 1 mark. They ask for the coordinates, so give it in coordinate pair form. Now for another mark. What is the value of w? W is lying over there in the equation, and we all know that here your vertical asymptote is located and there your horizontal asymptote is located. What is the value of w? Well, it's that dotted line. So w equals minus 1. Don't just write minus 1. Tell them w equals minus 1. That's for 2 easy marks. The next one says, calculate the value of k, and here they say t lies on f. Now we read it, now we know definitely it's on the graph of f. They want us to find the value of k. Now look at where k is. K is at the top over there. What do I have? For part C, t, because it lies on the graph, I'm going to use f of minus 2 is equal to 7. If x is minus 2 in f, the y value is 7. So f of minus 2 is 7 is equal to k over the x is a minus 2, and the w I just found was minus 1. Now again, it's time to clean this up. Algebraically, that's a fraction. Let's multiply with minus 2 throughout. Okay, so I'm going to take this side and that side, and I'm going to multiply both sides with this negative 2 that's in my denominator. Folks, you don't have to indicate this. Now, that type of thing happens in your head. Okay, so I get minus 14 equals k, the 2 cancels the 2 here. A minus 1 times a minus 2 is indeed a plus 2, and then all you need to do is throw the 2 over, then k will be minus 16. Now that's quite easy if you know what to do. We gave you a point on the curve. So you used the point on the curve. Once you plugged it in, you saw that the only variable left was k. And then you treat it again for what it is. It's a fraction. Get rid of this fraction by multiplying both sides. It's an equation. So you can multiply both sides with its denominator. And then it's gone. That was for 2 marks. The last part, for 5 marks, they're asking us to find the coordinates of P. Now we know that P is where the hyperbola crosses the line. Okay, Okay, so let's see. We've got the equation for the hyperbola. Let's write it down. F of x is now equal to k. Now k is minus 16 over x. The w we found to be minus 1. And we've got g of x. G of x is minus x minus 1. Now it's a simple process. Because it's where they intersect, I need to equate these two. Okay, so I start off by saying minus 16x minus 1 is equal to minus x minus 1. Okay, again, I have a fraction over here. Okay, now look carefully. Can you see there's a minus 1 on the left of the equal sign? There's a minus 1 on the right. They are going to say goodbye. If I throw that over, it becomes minus 1 plus 1. So I'm stuck with minus 16 over x, which is minus x on the right hand side. The negative cancels that negative if I divide them away. Okay, so all that's left for me is to take this x and multiply both sides of my equation. I'm going to times with x to get rid of this fraction. Oh, not 4, that's an x, sorry. Okay, so those two x's cancel. On the left hand side, I'm left with 16 is equal to x times x, which is x squared. And guess what? If you initiate the square root, x will then be plus or minus the root of 16, which is 4. Now let's go and look at our graph. That is true. That's the solution to that quadratic equation. But if we look at the graph, there's the y-axis. P lies on the negative side. So the x-coordinate for P must be negative. Therefore, the x-coordinate of point P is indeed minus 4. And that's all they wanted. Calculate the x-coordinate of P for 5 marks, folks. You don't have to find the y-coordinate. If they said find the coordinates of P, you will go and substitute this back into either the line, I think the line is going to be easier, and write down the coordinate P. Okay, that dealt with the functions, the hyperbola, and the line. The next question where we incorporated functions was question number 4. Okay, we gave you a set of graphs A, B, and C. Okay, and then at the bottom we gave you, what is it, 2, 4, 6, 8, 9 equations to choose from to match the equation with the graph. Now I'm going to do this the other way around. I'm not going to look at my equations that was given. I'm going to look at the graph itself. Okay, so I'm going to do it here. For number A, because this equation passes through the origin, it will have a standard equation y equals m of x. Okay, because the c value is 0. Now all I need to do is find the value of m. Now look at this. If x is 2, the y value is 6. So I'm going to make x 2 and I'm going to make y 6 and see what m is. Okay, let's have a look. 6 is equal to 2m. So from there, m is equal to 6 divided by this 2, which is 3. So my equation is y is equal to, the gradient is 3 times x. Now if I look at the options that I have here, from A, B, C, and D, you can clearly see it's D. We just left the 3 underneath the y here to confuse you a bit. Okay, so for graph A fits equation D. Okay, let's look at B. Well, B is a horizontal line, and all horizontal lines have equations y equals c. So for B, I've got the equation y is equal to c because its gradient is 0, so m is 0. What is the c? The c is negative 3. So I'm looking for this equation amongst the collection that I was given. Now if I look at it, it's number G. Okay, so this matches with G, number B. Now the nice one, the parabola in number C. Let's have a look. Well, I can see its roots are at 1 and minus 1. Its turning point lies at minus 2. Okay, so immediately I'm going to say y is equal to a times x minus root 1, x minus root 2, because I have the two roots and I have another point, which is my turning point. So immediately I'm going to gooi my roots in. X minus 1, x plus 1. So what do I have? I have so far y is a times x squared minus 1. Now I'm going to use this point. This point is the point 0 and minus 2, meaning that if x is 0, y is minus 2. So there I get minus 2 is a times 0 minus 1 is minus 1. So what is a? A is minus 2 divided by minus 1, which is 2. Okay, so what do I have? I have a final equation. Y is 2 times x squared minus 1. I put the 2 in there. And then I can look for different forms of that. So I could have written this as 2x squared minus 2 possibly. Now let's have a look. There we go. 2x squared minus 2 is number C. So folks, to answer a question like this, know your forms. Know that if this is given what it looks like, what do I do with it? Here I had 0, 0 as a point through which my line passes, which means that's the form of the line. Here there was a horizontal line. I had to identify that y is equal to C. Here I had two roots and a point. And to identify what to do with that, I had to start with my two-root formula, get it to that point, and then plug the other point in as a coordinate pair to find out what A is. Once I've done this work, I go and look for the options. I'm not going to say, oh, that looks like this, possibly like that, or possibly like something else. Okay, I hope that helped you guys.